Today I'm going to demonstrate how to create data tables in Math Minion. I'll be doing this on my Mac version, but the principles are the same with the iOS version. I have a completely blank diagram here, so I'll start by right-clicking on the background and adding a data table. I'll name this guy Bears, and I'll add my first column. I'll call the column Cited for the time the bear was seen. And that brings us to the initial value. This is the value that is assigned to this column whenever a new row is added to the data table. But it also has an additional function in that when it is first used, it determines the type of that column, whether it's a string or a number, and if it's a number, what type of unit it has. In this case, I'm going to use the function now, which is the current time. The initial value should always be something that can be evaluated, i.e. not relying on an unknown value, because obviously you need to have a value to add in. So if I go back here and add a row, you can see the unit is seconds. Math Minion times are seconds since January 1st, 1970, and it has a value. So let's go play with that a bit. Let's go back in and change the initial value to just 0 with no units. And I'll go back out and try and add another row. Well, I get one, but I also get an error saying that the unit type was mismatched. And that's because a fraction, no units, isn't a time value. So let's delete that row and go back in, and we'll put our now function back in, and we'll change the display units to something a little friendlier than seconds. Go back out, and yeah, that looks better. We'll add another row, and all is good. Okay, going back in and adding another column. This column I'll call name, and as that implies, it should be a string. So the initial value must be a string. So it could be just a blank string, but I'm going to call it unknown. So it's just a word in quotes. Now when I go back out to the table, you can see the new column is there. What's more, every row has been filled in with the initial value that we gave. In this case, just unknown. So let's call the first row Papa, and the second row Mama. You note I don't have to use quote marks when entering strings into a string column in a data table. Okay, another column. This one we'll call weight, and we'll give it an initial value of 0 kilograms. When I go back out, you see the column's been added with 0, and the units are indeed kilograms. So let's give it 250 kilograms for Papa. We have big bears around here. And 150 kilograms for Mama. Okay, another column. This one I'll call length. And I'll forget to give it a unit. Obviously it should have a unit of length, but I'm just going to leave it as a fraction. I'll go out, and indeed it's turned up here. So let's say I try putting in 2.2 meters for Papa. Again, error, because meters doesn't match fractions. So rather than fixing it, I'm going to just leave it at 2.2. I'll take the unit off, and I'll make Mama 1.8. And let's say I go on and I have a huge column like this, and I decide, well, I really would like to have units on that. Now the only option is to remove that column and add a new one, but adding all those values in could be rather tedious, but fortunately there's a easier way. Let's go back in here and add another column. And this one we'll call new length, and for its initial value we'll put $, which means the current unit operation, i.e. bears, length, which is the column that we've already have, times 1 meter. So when I go back, you can see we've now created a new column called new length, and it's been created by multiplying the fraction of the length column by 1 meter, so we now have units in there. Going back in, we can now get rid of the old length column. That's not needed anymore. And we can rename new length to length, and of course we have to change the initial value formula to be appropriate. And why don't we even change its display units to, say, centimeters. So now we go back out, and the column is the way we want. If we add another one, say baby, and now 80 kilograms, and 110 centimeters, all is good. The other way you can create tables is by importing them from CSV files, common separated value files. And I'll start by actually going the other way. I'll sort of export it. If I go over here and I right-click on the bears object, I have a copy as table menu item, and I'll select that. And I'll create an expression here. And for its formula, I'll start it with a single quote, because everything else will be a string, and I'll paste in what I just copied. When I look at that string, you can see that it is indeed a comma-separated value file, but it has 3 additional lines, header lines at the top. The first line begins with table. It must have that. And then that's followed by the separator, normally a comma, and a language designator, in this case English, and that affects how the numbers are formatted. The second line is always the names of the columns as quoted and comma-separated strings. And the third line must be the units of the columns. In the case of a string column, the unit should just be string. If I select all this text and copy it to the clipboard, and then go back over to the diagram and right-click and select Paste, a new object will appear, which is the data table represented by that CSV. And as you can see, it's essentially identical to the original bears one. I talked a bit about the international format. If I switch over to this other session and have a look at this string variable, you can see it has a semicolon as the separator, and the language designation is D for German. And indeed, all of the fields are now separated by semicolons, and a comma is used instead of a decimal point. Let me select this and copy it to the clipboard, and switch back to my original session here. And if I now paste that, I indeed get a nice little table. And that's it.